Find the 5-number summary for the data set shown in the table below. In this example, I'm only going to use technology to find the 5-number summary. And if you have something different than the TI calculator, then you just need to make sure you understand how that works in order to get these values. But if you do have the TI, just follow along with me. So I'm going to go into the list editor. So I press Stat and press Enter to get into that. And if I have data in there, you want to clear that out. So highlight the name of the list, press Clear and Enter. And then just start entering the data one at a time until we get all the data items in. Now, the nice thing about using the calculator is you don't have to worry about sorting your data to begin with. The calculator already knows how to do the sorting for you, and that's really where the time-consuming process is in getting the 5-number summary, is the time spent in sorting the data. So to get the 5-number summary, we'll use the function oneVarstats. So press Stat, go over to Calc, and the very first item is oneVarstats. If you see this menu, that's great. You can use it. Just make sure the data list, the first item, is reading L1. If not, press 2nd and 1 to make it read that. We did not use a frequency list, so make sure that's clear. If you're not seeing the menu, then just press 2nd and 1 to tell the calculator that your data is in L1. That's fine. And then press Enter, and it will run oneVarstats. And you can scroll down to the second page of output to get the 5-number summary, which in this case would be 10 for my minimum. Then it was 38.5 for Q1. Then 45, and I believe it was 57.5 for Q3, and 90 for the maximum. All right, so that's all we have to do to get the 5-number summary. The next question asks, what is the value of the interquartile range? Well, the interquartile range, there's a formula for the interquartile range. You just take the value of Q3 minus the value of Q1. So you are calculating a range, it's just the range between the quartiles. So in this case, we would do 57.5 minus 38.5, and let's see what we get. 57.5 minus 38.5. Oops. There we are, 19. So the interquartile range in this case is 19. What is the lower bound for an outlier? Okay, so when it comes to the bounds of outliers, so outliers, these occur any value that is, that's the inner. If we take Q1 minus 1.5 times the interquartile range, that's the lower bound for an outlier. And if I take Q3 plus 1.5 times my interquartile range, that's the upper bound for outliers. So any numbers outside of these two values are considered outliers. So let's check and see what the lower bound and upper bounds are for outliers in our data set. So if I take Q1, well, actually, I've already written the formula down, so Q1 itself is 38.5. And I'm going to subtract 1.5 times my interquartile range of 19. So I'll use the calculator to get that. So 38.5 minus 1.5 times 19. That gives me 10. So any number smaller than 10. And then 57.5 plus 1.5 times 19. So any value bigger than 86. So if my data set was sorted, it would be easy to tell which ones are outliers, but the next question is to list any outliers in the data set, and we separate them by commas. So let's take a look. So any value greater than 86. So if I scan through, I'm looking for any numbers that are bigger than 86. There's one. Okay, looks like just one to the upper end. And any value less than 10. Well, I have a 10, but it doesn't count as equal to. It's just a boundary, so we don't include the 10. So it looks like 90 is my only outlier.